My name is Dr. Esther Trufan, and in today's experiment, we are going to work on determining the density of various ethanol and water solutions. For this experiment, we're going to use deionized water and anhydrous ethanol. So not 95%, not 93%, but anhydrous ethanol. It will not work if we use different ethanol. So for this experiment, to make it easier on myself, I prepared two burettes. The burette on the right side has been charged with ethanol, and the burette on the left side has been charged with deionized water. I am going to release small amounts of each in a 10 milliliter graduated cylinder. And at the end, I am going to measure both the mass, for which I will need a scale, and the combined volume, for which I will need a 10 milliliter graduated cylinder. And I'm going to record my starting mass. The mass of my graduated cylinder is 25.27 grams. I need to record this because in case it takes me quite a bit of time to add my water to it and the scale turns off, it is better to work by additive measurements. We record our starting volume for the watering. It is 2.91 milliliters. We raise it up. And then we add approximately 7 milliliters, so to about 9.5 milliliters. I place my graduated cylinder on the scale and record the mass of my graduated cylinder with water, which is 31.94 grams. And then I will lower my burette so that I have the water level at my eye level. And it is 9.60 milliliters. I don't want to turn this off because next I will be moving on to my ethanol. I will lower the ethanol level to my eye level, make sure it is stabilized. And then I will record the volume. It is 3.48 milliliters. I'm going to raise it up. And I am going to add some ethanol to my graduated cylinder so that my final volume will be between 9 and 9.5 milliliters in the graduated cylinder. This gives me a little bit more space just in case it moves around a little bit. You can see there are some bubbles forming in the process, and we can add a little bit of mixing, but that bubble formation is really what's going to mix our ethanol and water. We just have to wait until all the bubbles are gone. And we can tap it a couple times. And while we wait, we record the final volume of our ethanol, which is 6.11 milliliters. And then we place our combined water and ethanol solution on the scale. We record our final mass, that is 34.07 grams. The masses are additive, but the volumes are not. So let's see if that's really true. We have a volume for our water and ethanol mixture of 9.39 milliliters combined in the graduated cylinder. But from the volumes, initial and end volumes for the water and the ethanol, we can determine the volume of water and the volume of ethanol that was combined. From the sum of those two, we can then subtract the volume of the ethanol and water mixture from our graduated cylinder. And that difference is going to be the volume lost in the process. This experiment can be repeated with any combination of amounts for water and ethanol the same way. Record the starting and end volume for the water and the ethanol, as well as the mass of the graduated cylinder, then with water and ethanol. From these, we can determine the mass and volume of water, mass and volume for ethanol, and finally, the mass and volume of the mixture. From mass and volume combinations, we will then be able to calculate the density of the water, the density of the ethanol, and the density of the mixture from each combination.